Hello guys, another video, and this time we're going to talk about the IK portion of the leg. And in the last video we went through the solver FK and we did improve upon, and I want to go through and do the same thing for the IK. So when we started building the solver IK in, I don't know, a bunch of videos ago, we created a very simple setup, and this setup is based on some naming, but then we left it at that. In those videos I did mention that I was on purpose skipping certain attributes, but today we're going to add those back in. So I removed the FK solver for now. We're going to build the entire graph bit by bit. But for now we're just going to have a look at the solver IK. So the solver IK is very similar in terms of structure to the solver FK that we just saw in the previous video. I've added this. There is the setup mode that we should be familiar with. Well, there is a sequence first, and the first thing is, are we in setup mode? If we are in setup mode, do we want the controls to be oriented like the bones? We saw this already in the previous video, but now while in FK, usually what I do is keep it on like this. For IK, usually, well, actually depending on where I am using the IK, I tend to use this off. And the reason I do this is explained in the first video of the module for the leg. And by default, if I turn orient controls, you can see that this control here, it's aiming towards the leg. Now the leg might look straight, but it actually has a little bit of curvature, and you can see that the control is aiming to the bone, which is going along the curvature of the leg. Then we said, actually for the IK, in order to have a much more clean animation editor, graph editor, to have clean curves, maybe we want to provide animators with a control alignment that makes more sense. Let's see what that means. If I have a look at the let me zero this out. If I have a look at when I move this up, this is moving up following the local space of the control, which happens to be the same alignment of the bone. While instead, usually, what we do is not having the control aligned to the bone. So if I untoggle this, you can see that this is switched. Let's have a look. This is switched, and now you can see that the Z is up and it is aligned to the world. And when I move up, it's actually a full clean up movement. So this is not true for every IK solution you might put in rigs. It really depends from the creature, but from a biped, which is what we're using now as a reference, I found that this gives animator a much cleaner way to think about their curves, because the up movement is an actual up movement. Same goes for the body control. So how are we doing this? We go into the solver IK, we say, are we in setup mode? And remember, the setup mode is basically what is set to the setup event. Setup mode is on. We are in setup mode. Do we want the bones to be aligned to the bones? The controls to be aligned to the bones? Let's say yes. You can see that this control gets aligned to the bones, and how it's done. That's done. I'm getting the bones, which are specified, by the way, as an input here, and they get the full transform. Okay, so this is the root. The root bone drives the root control, and the end bone drives the effector control. And when it comes to the pull vector, you should already be familiar. I'm solving the pull vector position procedurally, so this control gets dynamically placed based on a specific angle that this plane, this IK plane, resolves. And I'm setting here the control offset. So the solver pull vector, we went through this, but it looks like that. I'm taking the 3 bones, doing some very basic vector subtraction, and then I am scaling it by a certain distance. This scale, it's what's called pole vector offset, and then I'm outputting the pole vector, right? So yeah, again, this pole vector offset gets stored in the setup event. What if I don't want to orient the controls? Well, I'm setting the rotation, the quaternion here to 0 based on from a rotator, and then I'm doing basically the same thing I'm doing up here, but only in translation. Is exactly what I did on the FK solver in the previous video. And then the pole vector is always, because there's always a translation and outputting, is exactly the same. So these two nodes are identical. It happens both in true and false mode. Okay, what if we're not in setup mode? If we're not in setup mode, then we need to check if we are in follow mode. In the follow mode, just to you know, not to forget, the follow mode is the mode that allows us to have a quick way to have the IK controls, in this case, to follow whatever kinematics is coming. So you have to think it this way. I know that we're talking about IK and FK together, and eventually we will create an IK and FK solver as we saw in the past, but with these new attributes. But in general, every solver should know how to basically follow another kinematics. So it's not that this is implemented specifically to switch to FK. This is implemented specifically to have the bone driving the IK, because maybe what we would want is switch between IK and a different type of solver, not necessarily FK. And we always use the bone position as an intermediate step to figure out the position of the controls. So in usually FK drive the bones and the bones drive the IK, or vice versa. So I'm using the bones as a structure, as an intermediate structure, to define the position of whatever controls I want to move around. I want them to follow. But what if instead of, you know, having an FK and IK structure, we rather have like a, I don't know, a dynamic chain that is driven by a fabric solver? The same thing would apply. The fabric solver would drive the bones, and then if I put this IK mode in a follow mode, the IK would follow the bones. So it's not strictly, it's most of the time we're going to use it in conjunction with FK, but this is more generic. So in follow mode, I'm using simple projection. We went through this in the previous example. The reason why the simple projection is being used is because I don't want to assume that the controls are oriented to the bones, but rather I want them to be constrained to the bones when preserving the offset. And the pole vector is still computing based on the angle, so the position will always match because it's the same math. This node is the same as this node. The only difference is that when I'm following, I want to set the actual control position rather than the offset, because this is what is going to be animated. So I want the position of the pole vector to have values rather than having the current offset transform to be at 0. So we are in follow mode, the controls are following. And then if all of this is false, so we're not in setup mode, we're not in follow mode, then it's time to do just the actual IK. And this is the simplest of them all because of this node here that basically provides everything. We're specifying the bones. We're here, what I'm saying here is that I want this control here, the foot control, which does that, to output the transform of this bone, but based on this space, so I can use that transform as an effector. And this is an amazing node because it allows you to switch to compute a different set of matrices based on a different space. And then here instead I'm simply getting the pole vector control to drive the pole vector control. Compared to the simplified IK I described in the past, at the beginning of this series, I also added as attributes the primary axis and then the secondary axis, as well as the stretch. And all of these are nothing else than, you know, two vector types and then another Boolean, which are directly connected to the primary axis and secondary axis and stretch of the basic IK. The reason why I'm doing that is because I want my solver IK to handle even situations where the axes are not hard-coded, where, you know, right now we know in the previous example we saw that the axes were going down the x line, and then the pull vector was at -1 to point to the opposite, or where the y was pointing. But now you can specify these pull vectors as you know, as values in here, as well as saying if it's stretch mode or not. So in the end, this is you know, if we have a look at what happened. Oh, by the way, if you're worrying about this is just me. It's a very poorly made skin cluster. I just need to fix the assignment of these vertices. This is not a bug in the controller. This is me being lazy and not skinning it good enough to the bones. That's what's going on. So with this said, this is the rig graph. Let's see what happens, for example, if I turn on stretch. And of course, this being a Boolean, it can totally be controlled by a Boolean control type. You can see that the bone is now stretching instead of like doing that where the bone is not stretching. So let's compile once again to reset everything. So let's see very quickly, you know, putting everything together from what we saw from the previous video. Let's see if I drag a solver FK and another one. Well, actually, let me duplicate. So in the setup event, the order in this case doesn't really matter, and in this case it actually doesn't really matter in the forward solve because we're going to use a branch. But let's see if we can build some very basic form of switching like we did in the past. But now here we are really starting going into advanced concepts. So I want this to be the solver FK to be in setup mode. I want Tor in controls, and then when it comes to bones and controls, I want to say these are my 4 bones. I create a collection, and the collection goes here. And then I want my 4 controls. I create a collection, and the collection goes here. Now these controls are hidden. I temporarily them, so let me make it visible again by turning on gizmo visibility, and you can see once again suddenly the controls start appearing. And look at what happens. Just to recap what we did in the previous video, I want them to be oriented like the controls. So the same goes. So this is for the setup event, which takes care of placing procedurally these controls along using the bones as a reference. Let me duplicate that, and this time I can turn these both off and plug this again, which means first it's going to compute the solver IK, and then it's going to compute the solver FK. What this means is that basically everything that is happening here is getting ignored. So the FK is the only one that works now. For this reason, instead of doing that, I can simply detach it, add a branch node, remove this connection, plug for solve, and we say if this value is true, it's IK, if this value is false, it's FK. So how do we drive the branch? Through this condition. In this case, I created a simple leg IK-FK Boolean, and this Boolean here happens to be true by default, which means it's going to be an IK by default. And let me compile that. So I expect this to have IK behavior, and if I switch this to not be Boolean, to not be true, I expect the FK not to work at all, but rather the IK not to work at all, but rather the FK, like that. Now in this scenario, we're not using follow mode. We haven't implemented any switch in place, meaning that if I switch back and forth, it's not going to preserve the position like we saw in the past. We're going to build that again based on this new configuration of the solvers. So bit by bit, we're gonna analyze a little bit in depth how we can achieve this. And that's pretty much it for this video. Thanks.